All right, welcome. Let's get started. So what did we do first? Did we try simplifying the inside? Okay, that would be the wise thing to do. If you wanted to distribute that negative exponent to every factor, that also works, but you're going to get a really big number as the coefficient, right? The variables should be fine, but it's the coefficients that are going to give us the issue if we choose to do that right away. So why don't we simplify? The top and the bottom share a factor of 4. This is going to get us 5 over 4. This x to the negative 4 we can combine with this 4 on the bottom. And then this y to the negative 2 we can move to the bottom. So this is going to get us so far only the 5 on top. We get 4x to the 8th, y to the 2nd, and z to the 5th. This is all to the negative 3. All right, so we have that so far. We agree? Yeah, good. Okay, another thing that some people do is if you don't like the negative exponent right here, what you can choose to do is make it positive by switching the top and the bottom. And then that's going to make your exponent positive. So equals, I'm going to say that this is 4x to the positive 8, y to the positive 2, and z to the positive 5 over 5. Because I did that, this is now what in the exponent? Positive 3, right? Are you okay with that so far? All right. If you distributed the exponent of negative 3, you should get the same answer, right? So just watch, right? Then once we do this, we're going to take this 3, distribute it to every single factor on top. There's 4 of them. And then the 5 on the bottom. And then what that's going to give us is 4 to the positive 3. We're going to do power to a power. 8 times 3 is 24. 2 times 3 is 6. And then 5 times 3 is 15. Over 5 to the power of 3, all we have to do is simplify those numerical exponential expressions. This is going to get us 64, x to the 24th, y to the 6th, z to the 15th. Over 5 times 5 times 5 is 125. Good? Raise your hand if you got that. Okay, good. A good handful of you. Raise your hand if you almost got it. You made a little mistake somewhere. Okay, that's also fine, right? With practice, you guys are going to perfect it, and then you guys are going to hopefully avoid those little mistakes later on. All right, hopefully none of us are lost. If you are, for now, that's fine, because we have a couple days left for our quiz. Reminder, your quiz is on Wednesday. But we should be here. That says Chapter P, Section 2 continued. It should be P.2b, Part 2. All right, so we're doing rational exponents. All right, so rational exponents. Rational is just another word for fractional, right? So if you look through these examples, if you scroll through, notice that every single example has a fraction in the exponent. All right, all that is it's going to convert to a radical expression. All right, so our general rule is that if I have a to the m over n, that number on the bottom is going to become the index of your radical, right? So if we need a refresher on radicals, this number on the inside is called the index. All right, this number underneath the radical, we call that the radicand. And then very simply, this m is just your exponent. All right, so the number on top of the fraction is just going to stay the exponent. The n on the bottom is going to become the index of your radical. So here's an example. If I have x to the 1 over 2, the denominator here is 2. So I'm going to circle the denominator. And I'm just going to make a note that it's going to go out front as the index of our radical, right? I don't see a 2 here, right? Why is that? It's just because anytime you see a radical without an index, right, there's an imaginary 2 there, right? So if you don't see a number inside, you assume it's a 2. Another invisible math that shows up here is this 1. The number on top we know is the exponent. Anything to the first power is itself, right? So we can very simply just say that this is the square root of x without writing that. Any other number in the denominator is going to become the index just like it did before, just this time you need to specify. Okay, there is a 3 there. And then just like before, this 1 on top is just going to stay the exponent. Again, if the exponent's 1, you don't need to write it. All right, so I'll erase that. If there's any other exponent, you can do the exact same thing. This 3 on the bottom, you can write out front as the index of your radical. This is your index. And then this number on top, the numerator of the exponent, is just going to become the exponent of the entire expression. So you can write it like this. Okay, so let's start pretty easy. Right, 4 to the 1/2, this is a fraction in the exponent. How else can I write that so that it makes a little bit more sense to us? You guys can call it out if you want. Good, square root of 4, right? Do we all agree with that? The number on the bottom becomes the index of our radical. So then I know that this is going to become the square root of 4. The exponent is 1, so you don't need to write it. So what is the square root of 4? 2, right? Do you remember what a square root is? Hopefully, right? You're looking for a number multiplied by itself twice to get you that number underneath. So the square root of 4 is 2. All right, same exact thing with the next one. All right, if I have 27 to the 2/3, what number is the index?
3.
Okay, so we're going to take that 3. It's going to go out front as the index. The radicand is 27. What's our exponent here? 2. Good, guys. So I'm going to write all of this to the power of 2. We're going to do one thing at a time. It's definitely easier to do the cube root of 27 versus squaring it first and then taking the cube root, right? The order really doesn't matter, but it's easier to make it smaller and then bigger. So we're going to take that approach. What does this mean? What are we looking for here? Can anyone explain in words? The cube root of 27, what are we looking for?
A number that is...
Right, so you're looking for a number that when you multiply by itself 3 times, you get 27. Do we know what that is? 3, right? So 3 times 3 times 3 is going to get you 27. So I know that the cube root of 27 is 3. And then we still have that 2 in the exponent. All we have to do now is square it. So 3 squared is what? 9. All right, not bad? Okay, good. We can do the same thing with the next one. Again, the order of your steps might look different from mine. But what do we know about negative exponents? Okay, so if it's in the numerator, it needs to move to the denominator. This isn't already a fraction, so I'm going to write this over 1. And then to make it positive, I'm going to move it to the bottom. So then this becomes 1 over 81 to the 1/4. And then now we can do what we've been doing and convert this to a radical. Right? What would this look like as a radical?
1 over the square root, or the quadruple root of 81.
Okay, good. So we're looking for a number multiplied by itself 4 times. That gets you 81. What number is that? 3. Think about it. 3? You guys agree? Yeah, right? If you do, we know that 81 is 9 times 9. And then if you split that up again, you get 3 times 3. And then 3 times 3, it's there 4 times, right? So we know that this multiplied by itself 4 times is going to get us 81. So we get 1 over 3 as our final answer. All right, you guys try the next one. Okay, good. So what we're going to do is same thing as always. This 4 is going to become the index of our radical. This is going to be the 4th root of 16. This 3 in the numerator is the exponent, so this is the 4th root of 16 to the 3rd power. All right, you can break this down. You can use a factor tree if you want to, right? Break it down into 4 times 4, and then you get 2 times 2 times 2 times 2. So that is 2 4 times. So we know that the fourth root of 16 is going to get you 2, and this is raised to the third power. So 2 to the third power is 8. All right. Any issues with that one? No, good. Nice work, guys. So let's try the same thing here. Okay, guys, so again, this negative exponent means you're going to change its position. It's on the top right now. We're going to move it to the bottom. It's going to be 1 over 1,000 to the positive 2/3. And then from here, we do the exact same thing that we did before. This 3 is going to become the index of our radical. So we get the cube root of 1,000 to the second power. And then the cube root of 1,000, we see a whole bunch of zeros. Your brain should tell you, okay, tens, right? So we know that this is 10 times 10 times 10. So we get 1 over 10 to the power of 2, which is 1 over 100. Any issues there? Pretty good. Nice work, guys. Now let's explore 6 and 8. We'll do those together. Just because past few days we've had the same issues with parentheses, right? So what's the difference between 6 and 8? What's the base in number 6?
100.
100, right? It's just 100. So how should I interpret this? Where should this 2 go in front of? The whole thing or just the 100? Just the 100. So I'm going to put it right there. This negative is just hanging out on the outside. This is going to be negative the square root of 100. Your exponent is 1, so you don't have to write it. I'm just going to write it. And then we just have negative, whatever the square root of 100 is, which is what?
Negative 10.
So our answer is going to be negative 10. Good, guys. Negative 10. All right, let's try the same thing with number 8. What's the base in number 8? Negative 100, right? Oh, I skipped one. Yeah, I'm going to do 7 in a second, guys. Sorry. So we're going to do the same thing here. If we move that 2 in front of the entire thing, we interpret this as the square root of negative 100. What is that?
I don't think you can.
Okay, let's think about it. Well, your instincts are probably telling you something to do with 10. But 10 times 10 is 100.
Is that 10 times?
If you do negative 10 times negative 10, that's also positive 100. Okay, for now, guys, you can't do this. You can't do negative 10 times negative 10 and then get negative 100. These are both negative 100. So we don't know what I is right now. We'll get there in some weeks. So for now, we can say that this has no real solution. Okay, nice work, guys. So then let's try the same thing with 7. All right, how do we interpret this? Okay, so this is a negative 64. That whole thing is the base. Good. So then this 3 is going to go on the outside of the whole thing. This is the cube root of negative 64, all raised to the second power. Can we do the cube root of a negative? Yeah, right? What's that going to get you? Negative 4, right? Do we see why that is allowed? Because if you do negative 4 times negative 4 times negative 4, that does get you a negative, right? It turns back negative. So if you need a little general rule, if you have an even radical, so if you have a negative under an even radical, it's no solution. If you have a negative under an odd radical, the answer is just negative. So we just saw that in number 8, right? The negative is underneath an even radical, square root. That one was no solution. In number 7, it was under an odd radical. So that one does have an answer, it's just negative. So then we can say that this is negative 4 to the power of 2, and that's going to equal positive 16. These are some good examples. Why don't you guys try this whole page on your own? Okay, number 9. What did we get? Okay, so we can do the cube root of 27, which is 3. And then we can raise that to the 4th power. And 3 to the 4th power, if you work it out, is going to get you 81. All right, what do we get for number 10? Good, so we can do the square root of 64 and then raise it to the 3rd power. So we get the square root of 64 to the 3rd power. Square root of 64 is just 8, and then when you, again, work it out, you're going to get 8 times 8 times 8 is 512. All right, what do we get for the next one?
512.
Okay, I heard a couple different things. Let's work it out. You could, I wanted to flip it first, but I already wrote that, so I'm going to show you that it's fine if you change it to a radical first. So let's do the 5th root of negative 32. And this is all raised to the negative 4. Right? Remember, odd radicals, are those no solution or are those just negative?
Negative.
They're just negative, right? So does 32 have a 5th root?
Yeah.
Yeah, right? It's going to get you negative 2. So this is going to be negative 2. And then we can raise this to the power of negative 4. From here, since we didn't do it in the beginning, or at least I didn't do it in the beginning, you can now change it to a fraction. Over 1, move it to the bottom. This is going to be 1 over negative 2 to the positive 4, which is 1 over what? Good. Nice work, guys. All right. 12. Anyone had issues with 12? I heard a couple of you, right? That's perfectly fine. So, couple things that you could do is, like we always do, you could distribute that exponent right away to the top and the bottom. So why don't we try that? All right, so I'm going to take this negative exponent, put it on the top, put it on the bottom. That's going to get us 121 to the negative 3 over 2. And then we're going to get 100 to the negative 3 over 2. All right. So when we do that, couple things that you could do. You could simplify the radical first, or you can switch their positions. I'll switch the positions. Since they're negative exponents, we need to change it from the top to the bottom, bottom to the top. So this is going to get you 100 to the positive 3 halves over 121 to the positive 3 halves. What can we do now? You guys can call it. Okay, change it to a radical. So this 2 we can move out front. This 2 we can move out front. This is going to be the square root of 100 over the square root of 121. Both of these are to the 3rd power. What's the square root of 100? 10. To the 3rd power. What's the square root of 121? 11 to the 3rd power. And then what's 10 to the 3rd power? 1,000. Do we know 11 to the 3rd power? Good. You can show your work for that if you need to. Keep in mind, no calculator on your quiz. Okay. These look a lot harder than they actually are, right? So I'll give you guys a second to think about this one. All right? How many of you guys would have changed these to radicals right away? Wait, I heard that. What happened? What did we realize? Okay, because these have what? The same base, right? They have the same base, so you can do what to the exponents? Add them, right? It's not always going to be super complicated. Sometimes there's little rules that you can use to make it a little bit simpler, right? So do we all agree that we can add these exponents? So we get 6 to the 4 thirds plus 2 thirds. What does that get you? 6 thirds, which is what? 2. 6 to the 2nd power is what? 36. Super easy. See how you maybe would have had a hard time if you had done the cube root of 6 to the 4th?
Yeah.
The cube root of 6 to the second. Yeah. Keeping that in mind, how can you do the next one? Subtract the exponents. They have the same base, so I can say that this is 125 to the 7/3 minus 5/3, which is what? Nice, 125 to the 2/3. And now this looks good, super easy. You can take that 3, move it out front. We get the cube root of 125 to the power of 2. So we get 5 to the power of 2, which is good, 25. Nice, guys. Keeping that in mind, try the next one. It should be super easy. I'll give you guys maybe like 20 seconds. Good, because you can, again, just combine these exponents, and then we get r to the negative 8 over 9 plus 17 over 9. And then you get r to the 9 over 9. And that's r to the first, which is just r. Nice, guys. Super easy. Okay, let's try these. Can't always be that easy, right? Let's give these a try. Okay, so we see more things going on. Again, don't let it scare you. Do one thing at a time, right? What's one thing that we can take care of right now? Okay, what are we going to subtract?
The 3 and 4ths. Like
Three,
the ones that have like
the ones that have the denominator of 4? Sure, good, because we already see common denominators. So let's make this z to the 3 minus 5 is going to get you negative 2 over 4 over z to the negative 2. Do I need to show that? I'll show it. Yeah, sorry about that. Might have done it a little too fast. All right, I'm going to combine these. So what you guys were saying is we can combine these first because it looks like they have common denominators. So I'm going to make this z to the 3/4 minus 5/4. And now since they have common denominators, you can just subtract the top. 3 minus 5 is negative 2. All right, we agree with that? Okay. So then let me go ahead. I'm going to erase that now. Okay. So then this is going to be negative 2. It's fine, guys. Negative 2/4. Okay, that helped us a little bit. What can we do now?
Switch now.
Okay, sure, you can switch them. Sure, why not? They have negative exponents, so you can switch them. You get z to the second over z to the positive 2/4. Oh, okay, yeah, that's bothering you guys. That's fine. We'll change it to 1/2. Whoa, what did I do? 1/2. Okay. And what can we do from here?
We can subtract.
Okay, subtract the exponents. So this is going to be z to the 2 minus 1/2. What's wrong with that?
They don't have common denominators.
How do we get them to have common denominators? Good, multiply by 2 over 1, and I'm going to do times 2 times 2. So this is going to get us z to the 4 over 2 minus 1 over 2, which is z to the 3 over 2. If it's a variable, you can leave it with the fraction and the exponent. I don't need you to change it to the radical. Only if it's a number, just because if it's a number, there's a high chance that it does simplify. So if it was a number, I would want you to simplify it all the way. If it's a variable, you can leave it with an exponent as a simplified fraction. Okay, what about this one? What can we do here? I want to hear from new people. All right, really good thinking. So let's distribute that 15. So then we get x to the 1/5 times 15. And then we get y to the 2/3 times 15. All right, power to a power you can multiply. And that the bottom's just x squared. What do you get when you do 1/5 times 15?
3.
Just 3. What do you get when you do 2/3 times 15? Good. And then over x squared. How does that simplify now? Okay, the x's, you can subtract the exponents. 3 minus 2 is what? 1, so this is just x, and this is going to be xy to the 10th. Not bad. Nice, guys. Again, try not to get overwhelmed. I know that's kind of hard, but try not to get overwhelmed. Do it piece by piece. Now let's try 18. What do we think we can do there?
You can distribute that way, you can get like the same denominator.
Sure, let's distribute. We get p to the 3/4 over, why don't we do the same thing here? Let's distribute the 2. We get p to the 10/4. You could simplify 10/4. I don't want to. Do we see why? Because they already have a common denominator, so we're going to do p to the 3/4 minus 10/4, which is p to the negative 7/4. Now, I told you guys you don't have to change variables to the radical form, but there is still something wrong with this. Do you see what it is? The negative, I'm going to put this over 1, and we're going to move this to the bottom. This is going to be 1 over p to the 7/4. That's it. Good. Any questions so far?